Everyone, we have the group number 4, and this project is the reduction in the production time of the Bonac 2 line at IPAC. This is the member group, and the continent we have the company which we are working is the IPAC, a metallurgical company that is dedicated to the certain profiles, cover, collaborative platen, and the product on which we will focus is the galvanized steel sheets. And remember of the definition state, we have the variable which the reduced cycle time ensures product quality, which depend of the following variables is the x1, 2, 3, 4, and 5. Furthermore, this was a definition of the problem before and the general objectives of this project. Continuing, we have the factor stratification, in which the company has two shifts, but we will focus on the shift 1 from the 7 a.m. and 3 p.m. since the production level is the constant and does not vary much. In addition, we will focusing on the production start, which is the galvanized steel sheet is the graph below. You can see the average sales, but due to the confidential request, we can place the real sales values. And we will have to focus on the production line 2 since it has the data more complete and reliable. Now, how's the definition problem statement focus? Next, please. And we can define the focus problem, which the IPAC 1 and 2 is have a customer service of the 2,426, and we want to reduce to 324. And the below is the objective focus, and the graph is the production time with the production time for production lot. And the stabilize and ice, which 3 point, we can conclude that the process is not stable over time and must be improved.
Okay, to carry out the analysis of the process, we had chosen to use the OTIDA flowchart to observe the time that each one takes the activities, as well as the number of operators that carried out the activities. By mapping the set process, we had classified the activities in at value but not necessary, and not at value, representing 20.5%, 63.5%, and 16.5% of the total time in the process, respectively. Additionally, 3 bottlenecks had been identified which occur in the coring machine when carrying out the calibration activity. Because the process is delayed, the material accumulates before the coring activity, which causes performance to drop of the production line. In this table, we can see that 2 activities had also been identified that are hidden factories. The first is unplanned downtime, which occurred because there is no defined preventive plan for the machines, which causes inefficiency in the production line. The second hidden factoring activities is the inefficient inspection, because the first stage on the inspection in the most quizzes operators don't carry out a thorough inspection, and this generates product waste.
We have the data collection plan with variables, the operational activity of each variable, the operational definition, the stratification, as we said, this is sheet, product, and line, the measure that in this case all is 4 seconds, the data type that's continuous for all variables, the where to collect, in this case in IPAC SA, when was collected on January 2023. How to collect, we will use the sample data and historical data for all variables, the why to collect, and the person who collect, that in this case is project leaders. We can set the variables, and also we establish one critical variable too. The current state of the variables will help us to cooperate it with the improvements, implement, and simulate in flexing. You can say the data, and also the method. For this method, we use the quantity variables of the historical data. For example, the mean, the standard deviation with confidence percentage between 20 and 25, 19 and 95%, resulting in a number of 112 samples.
Since the company provides us with historical data, we proceed to perform a two-sample t-test to check the reliability of this data. For each of the variables, a comparison was made between historical data provided by the company and bill of data, which were taken by us over a period of a month and a half, and to determine the sample size, the formula percent about was used. As a result of this analysis, we found that the data is reliable for each of the variables such as y, x1, next please, x2, x3, x4, and x5, including the data for the critical variable x6 that is business days required for delivery.
Now, regarding the stability analysis, we had used the EMR chart. So in the graph, you can see that in the graphs on the mean and variation of the process, there are 3 points that are upsize the limits of the control graph, that is the data has at variation. Therefore, it's concluded that the process is not stable over time. On the other hand, when performing the normality test with which was obtained a p-value of 0.01, since is lower than 0.05, therefore concluded that the data are not normally distributed. Finally, we have carried out the capacity analysis. However, before doing so, we have modified the process by converting the data to normal. From this, a short-term capacity of 0.76 and a long-term capacity of the 0.59 is obtained, which concludes that the process is not capable and needs to improve since the CPK and PPK are less than 1.33.
We see the next step, quick analyze step, and next we can see the evidence of this project, which supervisor production. Thank you.